Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 4.2 Applications, Problem 1. This is Section 4.2 Applications, Problem 1. It says Billy's Bountiful Bicycle Company manufactures 3 types of bicycles: racing bicycles, touring bicycles, and mountain bicycles. The production of these bicycles requires the use of both steel and aluminum. The company has 91,800 pounds of steel and 42,000 pounds of aluminum. Each racing bicycle requires 17 pounds of steel and 12 pounds of aluminum. Each touring bicycle requires 27 pounds of steel and 21 pounds of aluminum. And each mountain bicycle requires 34 pounds of steel and 15 pounds of aluminum. The racing bicycles have a profit of $180. The touring bicycles have a profit of $110. And the mountain bicycles have a profit of $110. How many of each type of bike should the company make in order to maximize their profit, and what is the maximum profit? So that's a big problem. So first we have to set it up. That's a 4-step process to set it up. We have to name our variables, write the object function, set up the constraints, and include that each variable is greater than or equal to 0. Once we set it up, then we have to solve it. So in order to set it up, step 1, identify your variables. Your variables are the things that are being made. And in this case, the things that are being made are the 3 types of bicycles. So the first type mentioned is racing bicycles. So I'm going to call that not just x, but x1. x1 equals, and we can just put racing. We don't have to write bicycle because they're all different types of bicycles. x2, the next type of bicycle mentioned, a touring bicycle. So x2 will be touring. And x3, the third thing being made, are mountain bicycles. And again, we'll just write mountain. You don't have to write bicycle. Now, if there were just 2 products, I would label them x and y. More than 2, they're all x with a little subscript. So if they made 5 types of bicycles, we'd have an x4 and x5. This is 3, so we have x1, x2, x3. This is step 1 of the 4-step process to set up the problem. Identify your variables, so we've identified them. Step 2 is to find the object function, look for information that's typically about profit, usually near the end. And this problem is a fairly standard problem. Near the end of it, it mentions how much profit for each type of bicycle. So we are going to want to maximize z equals. So the profit for the first type of bicycle, which is racing bicycle, is $180. The racing bikes have a profit of $180. So 180 x1. Again, x1 is racing bicycle, and it's $180 for each racing bicycle they sell the profit. The next type is touring bikes. Touring bikes have a profit of $110, and touring bikes are x2. So plus 110 x2. Again, x2 are touring bikes, and each touring bike generates a profit of $110. And then plus the last type, it says, and the mountain bikes also have a profit of $110. So, and the mountain bikes are x3, so plus 110 x3. So step 2 of the 4-step process is write out the object function, and here we have the object function. We want to maximize it. We have the amount of profit for each type of bicycle times the variable that represents each bicycle. Step 3 is set up the constraints. That's where the most work is, to set up the problem. So for the constraints, we're going to write subject to and now what's going to limit the number of bicycles that they're able to make is the amount of steel and the amount of aluminum. So we're going to have 2 constraints. And I'm going to leave myself a little bit of room, and I'm going to write out here 91,800. That's the amount of steel. And I'll label that steel. You don't absolutely have to label it, but I think it makes the problem a little bit easier and more organized. And the other constraint is the 42,000 pounds of aluminum that's available. So 42,000, and that is aluminum. Now, each constraint is going to have a less than or equal to. Again, if there's 42,000 pounds of aluminum available, you can use up all 42,000 pounds. You can use 39,600 pounds, but you can't use, say, 42,100. It has to be 42,000 or less, because 42,000 is all you have. Same reasoning for the 91,800 pounds of steel. Less than or equal to is what you need. Now, we'll take it apart sentence by sentence. It says, let's see, racing bicycles are the first one. So here we have it. Racing bicycles, each racing bicycle requires 17 pounds of steel and 12 pounds of aluminum. So 17 steel and 12 aluminum for the racing bicycles. Racing bicycles are X1. So in the steel constraint, we have 17X1. And for the aluminum constraint, it was 12. So 12X1. So again, X1 is racing bicycles. Each racing bicycle uses up 17 pounds of the steel that's available and 12 pounds of the aluminum. And now the next type of bicycle is touring. That's X2. So I'll go down to the next sentence. It talks about the touring bicycle and how much materials they use. So each touring bicycle requires 27 pounds of steel and 21 pounds of aluminum. So in the steel constraint, we're going to have 27X2 and 21X2 for the aluminum. So again, the touring bicycles are represented by X2. Each touring bicycle uses up 27 pounds of steel and 21 pounds of aluminum. And then finally, the mountain bicycles, they're listed last, says each mountain bicycle requires 34 pounds of steel and 15 pounds of aluminum. So 34 pounds of steel for each mountain bicycle, which is X3, and 15 pounds of aluminum for each mountain bicycle. So again, the mountain bicycles are X3. Each mountain bicycle uses up 34 pounds of steel and 15 pounds of aluminum. So that's the constraints for this problem. Step 3 is set up your constraints, and we've done that. Step 4 for the setup is each variable used has to specifically be mentioned that it is greater than or equal to 0. So we cannot make a negative number of bicycles. We could make 0 bicycles, can be equal to 0, equal to or greater. Can't make a negative number of bicycles. So now the problem is set up. This is what we need to solve. Now, in order to solve this problem, we need to use the simplex method, or in other words, turn it into a matrix, pivot it. This one cannot be done graphically, or not by most normal people. Graphing the feasible region, it would be in 3 dimensions. It would be too difficult. So let me go to a different color and start setting up what's going to be the matrix. So to make this a matrix, what we have to do is take our constraints that are less than or equal to, convert them to equations by adding a slack variable to each one, and then rearrange my object function so that the variables are going to line up with the other equations that I make. And the greater than or equal to zeros don't need to go in the matrix. Now my first constraint for the amount of steel used, the 17X1 plus 27X2 plus 34X3 is less than or equal to 91,800. I'm going to rewrite that as an equation, and it's going to be 17X1 plus 27X2 plus 34X3 plus S1 for slack. I'm going to leave a little bit of a space. And I'm going to put equals now instead of less than or equal to, equals 91,800. So now it's an equation. It was a less than or equal to, now it's an equation. The second constraint for the aluminum, which is 12X1 plus 21X2 plus 15X3 is less than or equal to 42,000. I have to convert that also to make it equal to 42,000. So the equation I'm going to make from that is 12X1 plus 21X2 plus 15X3 plus, and now I space over a little bit and I put plus S2. I don't want the S1 and S2 to be right over and under each other. Different variables. And now I'll put equals 42,000 instead of the less than or equal to that it was. Now, The next bunch of constraints with the greater than or equal to 0 do not have to go in my matrix. I should see that they're there. I see them. I'm all set with them now. They don't have to go into the matrix. But the object function needs to go into the matrix. The maximize z equals 180x1 plus 110x2 plus 110x3. That has to go in the matrix. It's already an equation, so it doesn't need a slack. But it needs to be rearranged so all the x variables are on the left side of the equals, because the way the problem's originally written, that 180x1, 110x2, 110x3 is on the wrong side of the equal sign. It's on the right-hand side. So as I bring that 180x1 over to the left to line it up with the other x1s from the other equations, it's going to become negative 180x1. And then the next piece of my object function, the 110x2, will also move to the left side of the equal sign, making it a negative 110x2. And again, I line that up under the other x2s from the other equations that I've already written. And finally, the last piece of my object function, the 110x3, also going to move to the left side of the equal sign, become negative 110x3. I don't need any slack for this one because it starts off as an equals, but I do have to account for the object variable z. So I'll put a z and then equals. And then what's on the right-hand side of the equation after I've rearranged it is a 0. So now my problem has been written as a group of equations, not inequalities, and the equations are written so that all the variables line up. Now I'm ready to turn this into a matrix. So now let me move over a little bit to the right, and I'm going to set up a matrix, and I'm going to label my column headings. So in terms of my x variables, I'm going to have x1, x2, x3. Then let me space those out a little better. Then in terms of my slack variables, I'll need an S1 and an S2. Then I'll need a column for Z. And the last column I will label RHS for right-hand side. So the top equation, when they're written as equations, was 17x1 plus 27x2 plus 34x3 plus S1 equals 91,800. That's going to go into my matrix. The x1 column just gets a 17. The x2 column gets a 27. The x3 column gets a 34. The S1 column gets a 1. S2 gets a 0. Z gets a 0. And the RHS column gets a 91,800. Now the second equation I had was 12x1 plus 21x2 plus 15x3 plus S2 equals 42,000. So that's going to be the second line of my matrix or initial simplex tableau. So on the second line of that tableau, the x1 column gets a 12. Oops. The x2 column gets a 21. The x3 column gets a 15. The S1 column gets a 0. S2 gets a 1. Z gets a 0. And right-hand side column gets a 42,000. And now there's one more row of my matrix from the one more equation that I have from the problem. The last equation was negative 180x1 minus 110x2 minus 110x3 plus z equals 0. So as I make that a line in my tableau, I'm going to have negative 180 in the x1 column, negative 110 in the x2 column, negative 110 again for the x3 column, 0 for S1, 0 for S2, 1 in the Z column, and 0 for the RHS column. So that's the initial simplex tableau. So now what we have to do is figure out where I'm going to pivot it and perform the pivot. So to find the pivot, what I have to do is first identify the pivot column by finding the most negative value in the bottom row. So as I look in the bottom row, my negative values are negative 180, negative 110, and another negative 110. The most negative value in the bottom row is the negative 180. That occurs in the x1 column. So the x1 column will be my pivot column. So the x1 column has a 17 in the top position, 12 in the middle position, negative 180 in the bottom position. It's either the 17 or the 12 that's my pivot. My pivot can't be negative, so I don't even consider the negative 180 as possibly being the pivot. So which is it? Is it the 17 or is it the 12? Well, to determine which one, we have to calculate the ratio of right-hand side value over pivot column value and go with the lowest positive ratio. So this may involve my calculator. So in the top row, the ratio of right-hand side over pivot is 91,800 from right-hand side over 17 for pivot. So that's not something that I'm reducing easily in my head. So at the calculator, 91,800 divided by 17 equals, it gives me 5,400. So that's my ratio. And I'll compute the same ratio for the second row of my matrix. The right-hand side value is 42,000. Over the pivot column value is 12. And again, I can see that it reduces pretty good. They're both even, but the calculator will do it pretty quickly for me. So 42,000 divided by 12 equals 3,500. So now between those two possible ratios of 5,400 from the top row and 3,500 from the second row, I want the smallest positive ratio, which is 3,500. 3,500 is smaller than 5,400. They're both big, but 3,500 is smaller. So now what's going to happen is I am first going to turn the 12 into a 1, because the 12 is where my lower ratio of 3,500 came from the 4,200 over 12. So the x1 column, as I had mentioned, had a 17, a 12, and a negative 180. It's the 12 that's the pivot. So in other words, it must become the 1, and then the rest of that x1 column has to turn into zeros. So when I do that, when I make that 12 into a 1, the top row with the 17 won't change yet. It'll change on the next step, but for now it'll stay the way it is. So the top row is 17, 27, then 34, then 1, then 0 again, then 91,800. That won't change for a minute. Now the second row is going to change. It has a 12 in the first position of the second row. It has to become a 1. So what I'm going to do is I'm going to make a new row 2, which is 1 over 12 times the entire row 2. This could get a little messy, so I'll get my calculator ready. The first one is easy. 1 over 12 times 12 is 12 over 12, which reduces to 1. I can do that pretty easily. The next one, 1 over 12 times 21, is 21 over 12. And 21 over 12, they both reduce nicely by 3. So you get 7/4. And 7/4 is 1 3/4, right? 8/4 is 2, so 7/4 is a fourth left, 1 3/4. Or if you like, 1.75. This might be easier to keep it going as a decimal. That way I can use the calculator as I make some of my zeros. The next position in row 2 in the x3 column is 15. So I'm going to multiply 15 times 1 over 12. 15 times 1 over 12 is 15 over 12. And it does reduce. They both reduce nicely by 3. So it reduces to 5/4, or 1 1/4, which I can write as 1.25. And the next one's easy. 1 over 12 times 0 is 0. The zeros are nice to work with. The next position in row 2 is a 1. So 1 over 12 times 1 is 1 over 12. It does have a decimal equivalent, but that gets a little bit messy. I'm going to leave that as a fraction, as 1 over 12. The next value in the z column of row 2 is 0. So I do 1 over 12 times 0. That stays 0. And finally, the RHS position in row 2 is 1 over 12 times 42,000. Not something I could usually do in my head, but I already did the computation, not even a minute ago, so I know the answer is 3,500. And in terms of making the pivot position into a 1, it's not going to involve row 3 of the initial simplex tableau, so I can just copy row 3 into the next tableau as is. So it'll stay negative 180 for the first value, negative 110 after that, negative 110 again. Then I'm going to have 0, 0 again, then 1, then 0. So, and let me keep a circle on my pivot element. This is such a large matrix, and it has a lot of other ones in it. Let me keep that in mind, that that's my pivot. Now, The next part of the process is to turn the other two values in the x1 column, the 17 in the top and the negative 180 in the bottom, turn those into zeros, and see if it wipes out the other negatives or if I need to pivot again. So, and let me again go to a new color, just to keep each tableau clearly separated. Now, in the x1 column, I have a 17 in the top position. That 17 has to become a 0. So I'm going to write a little equation next to row 1 and explain how I'm going to turn that 17 into a 0. So my equation is going to be row 1 equals some stuff plus the old row 1. Now, my little equation starts with row 1 because row 1 is the row where I'm making the 0 at this point. And my equation ends in row 1 because it should begin and end in the same row. Now, the space I leave in the middle and I describe as stuff is going to be the row with the pivot position, which at this step is row 2. And it's going to be multiplied times the same number but opposite sign is what's being turned into a 0. What's being turned into a 0 is a positive 17, so same number opposite sign is a negative 17. So the equation I'm going to use to make my new row 1 is row 1 equals negative 17 times row 2 plus the old row 1. Now, with the fractions, that could get a little messy. Fortunately, there's a few zeros that'll help us out. I'm going to keep my calculator handy to help. So in the x1 column, I'm going to do 17 times row 2 is 17 times 1, or negative 17 times 1, that's minus 17. I'm going to add the result to row 1. So I'm going to add negative 17 plus positive 17, 0. So that one's good. The next one might be a little messy. Negative 17 times 1.75, add the result up to the 27 on the top. So let me use the calculator to help me. So negative 17 times 1.75 gives me a negative 29.75. And I'm going to add that negative 29.75 plus a positive 27 gives me negative 2.75. That wasn't as bad as I thought it might have been. The next one, again, could get a little messy. So negative 17 times row 2 is negative 17 times 1.25. I'm going to add that answer to row 1, so I'm going to add the answer to 34. So negative 17 times 1.25 is negative 21.25. Then I'm going to add that negative 21.25 to the row 1. So I'm going to add negative 21.25 plus 34. And it gives me positive 12.75. And then the next few will go easier. So in the next column, the S1 column, negative 17 times 0 is 0. Add that answer to row 1, so I'm going to add 0 plus 1. That's 1. The next one, negative 17 times 1/12, is negative 17/12. Doesn't really reduce, but that's okay, because you're going to add it to the value in row 1, which is 0. So negative 17/12 plus 0 is negative 17/12. That's fine. And the next column, the z column, I'm going to go negative 17 times 0 is 0, plus another 0. That's the value in row 1. So 0 plus 0 gives me a result of 0 for the z column. And now the next one is negative 17 times row 2 is negative 17 times 3,500. It's a big number, but no fraction, so it stays whole numbers. So negative 17 times 3,500 is negative 59,500. So I take that result, add it to row 1. So what I'm going to add is negative 59,500 plus positive 91,800. Which again I'll use the calculator for, and it gives me a result of positive 32,300. So I've completed my new row 1, which involved making a 0 in the top position of the x1 column. The next row, I don't want to change anything. The next row has the pivot position, which is a 1. I don't want to change that at all, so I'm just going to keep row 2 exactly the way it was from the previous tableau. So the x1 column has a 1, the x2 column has a positive 1.75, x3 column has a positive 1.25, the S1 column has a 0, the S2 column has a 1/12, the Z column has a 0, and the right-hand side column has a positive 3,500. No change. And finally, the bottom row. So in the bottom of the x1 column right now I have a negative 180. I want to change that to a 0. So we're in row 3. So next to row 3 I'm going to make a little equation. And the little equation is going to start off by being row 3 equals some stuff plus the old row 3. Now my equation is starting with row 3 because that's the row I'm making the 0 in. It ends with row 3 because the equation should begin and end with the same row. And now for the stuff, what I call stuff, the stuff is the row with the pivot position, which in this problem is row 2. And it's going to be multiplied times the same number opposite sign as what's becoming a 0. What's becoming a 0 is a negative 180. So the same number opposite sign is a positive 180. So the equation I'm going to use to make my new row 3 is row 3 equals 180 times row 2 plus row 3. And that'll make my 0, because in that first x1 column, 180 times row 2 is 180 times 1. Take that result of 180, add it to row 3, so you can add 180 plus a negative 180, 0. Now, the next two columns are what's most interesting. When I perform the work in my equation of row 3 equals 180 times row 2 plus row 3, is it going to eat up these negatives, or is it going to leave them negative? The negative 110 and the negative 110 again after that. So again, let's get out the calculator. I think it's going to work. So 180 times row 2 is going to be 180 times 1.75. That gives me a result of positive 315 when I do the multiplication. I'm going to add the result I get to row 3. So positive 315 plus a negative 110. So essentially I'm doing 315 minus 110 is 205. Positive 205. And now for the next one after that, in my x3 column, I'm going to do 180 times row 2 is 180 times positive 1.25. Get the result, add it to row 3. So I'm going to add it to negative 110. So with the calculator, 180 times positive 1.25 is positive 225. I'm going to add that positive 225 to a negative 110. So essentially 225 minus 110 should be 115. Just verify that real quick. So positive 115. And now the rest has to come out positive. So the S1 column, I have 180 times row 2 is 180 times 0. That's 0 plus that result plus row 3. So I do 0 plus 0. The end result for the S1 column is 0. The next value is 180 times 1 over 12. That's 180 over 12, which should reduce. So let me just with the calculator do 180 divided by 12, which is the same as 180 over 12. And it does reduce to 15. That's nice. So I'm going to do 180 times row 2 is 180 times 1 over 12, which gives me 15. I'm going to take that answer, add it to row 3. So I'm going to add 15 plus 0 is 15. And the next column is very easy, the Z column. 180 times row 2 is 180 times 0. That gives me a result of 0. I'm going to add that result to row 3, so I'm going to add 0 plus 1 is 1. And finally, the RHS column. So I'm going to multiply 180 times row 2 will be 180 times 3,500. Again, a little too big to do in my head. It gives me a result of 630,000. So I'm going to add that result to row 3. So I'm going to add 630,000 plus 0. That I can do in my head. That's 630,000. Now I have completed the pivot. The x1 column has been pivoted. I made the one first where it had to go, which is in the middle position. Then I turned the rest of the column into zeros. And now that I've finished that pivot and I examine my bottom row, I see that there are no negatives in the bottom row, which makes me really happy because I didn't want to pivot this big matrix again. So what that means is I found the maximum. So the profit from selling bicycles started with a profit of 0 in the initial tableau, wound up with a profit of 630,000 after one pivot. So pivoting again is not going to make this go up. So now to state your solution, I'm going to say maximum profit of $630,000. And now, how many bucks do you make to get that $630,000? So I'm going to say by making So first in the x1 column, which was racing bikes, x1 represents racing bikes, the x1 variable does have a value. In my final tableau in the x1 column, I have one of those special columns of all zeros and a single one. So now the height of the 1 is in the middle. So when I go to the very far right column, the value in the middle at the same height as that 1 is 3,500. So the answer for x1, or the number of racing bikes, is 3,500. So by making 3,500 racing bikes, the next column, the x2 column, represents touring bikes. As I look in the final tableau, the x2 column, I do not have a special column of all zeros and a single one. That means the value for x2 is 0. So in other words, you're not going to make any touring bikes at all. So no touring bikes. And the x3 column represents how many mountain bikes. Now as I look in the x3 column of my final tableau, again, it does not have a special column of all zeros and a single one. So the value for x3 then is 0, which means you don't make any mountain bikes either. So, and no mountain bikes. So essentially the racing bikes are selling for the most profit, and you're just going to make all racing bikes, and you're not going to make any of the other type of bikes, and that'll make the most profit possible for you. $630,000 by making 3,500 racing bikes and no other type of bikes for this company.